Hello, welcome you all. Today we will discuss about the continued concept of the chapter electricity. So in this chapter we will discuss about the concept of resistance. Before understanding the concept of resistance, I will tell you one very simple example. Imagine you are traveling on the surface of a road, and if you are moving very speedily and if you want to stop immediately, what the government it will do is, it is going to use certain type of road breakers on the surface of the road. What you will do is, you are going to reduce the speed of your vehicle like this type only. If you want to control the current which is flowing on the surface of the wire, at that time we will use one special physical quantity, and that quantity is called as a resistance. Here you can observe, this is a symbolic representation of the resistance. The zigzag shape what you are using, this is indicating opposition. Opposition for what? Opposition for the flow of the electrical current. So that's why we can simply say it as the opposition offered by the conductor. You know already, conductor means the material which allows the heat and electricity to pass through it. Generally we are going to make use of the copper and aluminum type of a wires, right? Like this type, the opposition offered by the conductor for the flow of the current through it. The opposition offered by the conductor for the flow of current through it, or simply you can say that the opposition to the flow of the electrical current, it is generally called as a resistance. This is the symbolic representation of resistance, and this is generally given by the formula R is equal to V divided by I. You already know that V is indicating the electric potential, or it is also called as the potential difference also. Suppose if your home is having one wall clock, right? In the wall clock you are making use of one cell. That cell is included of 1.5 voltages, right? That is called as the electric potential. For home purposes you can make use of 220 to 240 voltages. It depends upon the situation. So this V is indicating the electric potential and I is indicating the electrical current. So simply we can say the formula of resistance as R is equal to V divided by I. And also remember, the system of international unit or SI unit which is used for the resistance is ohm, OHM, ohm. Actually it is a Greek symbol, Greek alphabet. This is read as a ohm. And also remember that resistance is generally considered as a scalar quantity. You already know the quantity which has only magnitude, that is simply called as a scalar quantity. So this is explanation about the resistance. And generally in examination they will ask you, define resistance and write the resistance dependent factors. Now I will tell you some of the important factors on which the resistance of a conductor depends. Remember, here 4 important things are there to control the resistance. Among them, the first important factor is length of the conductor. I will tell you one simple example. Here there is one conductor, you can observe. This is a wire, and imagine this wire is about 20 centimeter. And I will take one more conducting material. Here you can observe this conducting material. This is having length about 1 meter. Okay, here it is only 20 centimeter and it is 1 meter or 100 centimeter. Remember, the amount of current flowing through the any type of a wire which is having less amount of length, at that time what will happen? If there is a less amount of length, then there is a less amount of resistance. That is, resistance is directly proportional to the length. If you increase the length, resistance also increases, and if you decrease the length, resistance also decreases. Imagine for your home I am sending the current, we are sending the current about 10 meters of conducting wire is there, and one more wire is there, same type of a wire and same type of a thickness is there, and that is about 50 meters. The 10 meter wire, that is having less amount of resistance, and 50 meter of wire, that is having more amount of resistance. So do remember, resistance is directly proportional to the length of the conductor. And second factor is the area of the cross section. Here you will get some confusion. Resistance is inversely proportional to area of cross section. I will tell you very clearly what this area of cross section is. Observe this wire properly. This wire is very thin in nature. Very thin in nature means its area is very less. And you can observe this conducting material. This conducting material is having large amount of area. That means area of cross section is more. The same concept is used here. If there is a large amount of area of cross section, there is a less amount of resistance. And if there is a less amount of area of cross section, if you reduce this area of cross section, the resistance value goes on increases. So do remember, the wire which is having more amount of thickness, that is having less amount of resistance. I will tell you one very simple example. Street wires are there. Street wires, they are having large amount of area of cross section. In that sense, the resistance will be very less for that content. And I will tell you one more simple example. Tungsten wire is there at your home for bulbs. That tungsten wire is very, very thin in nature. Thin in nature means very less amount of area of cross section, then the resistance will be large. So that's why it consumes a large amount of power. So this is what the second factor on which the resistance of a conductor depends. And third type of a factor I will tell you, that is the temperature. The temperature in the sense, suppose there is a large amount of temperature in the atmosphere, or if there is a large amount of temperature which is present inside the wire also. At that time what will happen? If you increase the temperature, the resistance of the conductor will also get increases. And if there is a less amount of temperature, then the resistance will be also very, very less. And the last factor it depends upon is nature of the material. Nature of the material in the sense, suppose variety of components of electrical components are there. Some of the electrical wires are made up of aluminum, copper, and variety of components. Among them, it depends upon the nature of the material also. That means among all the conductors, the silver conducting material or silver wire, it is having very less amount of resistance. And if you take the examples like tungsten or nichrome or some other type of any type of a alloy wire, that is having large amount of resistance. Imagine your friends and you are standing, if you are having a running competition, 10 members are there, among the 10 members the running competition is going to take place. At that time all will not come for the first position. Only a single person who is having more amount of stamina, he will come first. Like this type, all the conducting materials are not having same amount of resistance. The material like silver, that is having very less amount of resistance, and some of the materials like tungsten and nichrome and other type of alloys, they are having a very large amount of resistance. So this is what the explanation about the resistance and resistance dependent factors. And this can be asked for 2 to 3 marks question in your main examination. Define the resistance and write the factors depending on the resistance, and also they will ask you define resistance and write its SI in it and write its formula like this type. Thank you.